Section 9.2, Fault Tolerance with Spring Cloud Circuit Breaker and Resilience4J. As you know, resilience is a critical property of cloud-native applications. One of the principles for achieving resilience is blocking a failure from cascading and affecting other components. Consider a distributed system where application X depends on application Y. If application Y fails, will application X fail too? A circuit breaker can block a failure in one component from propagating to the others depending on it, protecting the rest of the system. That is accomplished by temporarily stopping communication with the faulty component until it recovers. This pattern comes from electrical systems, for which the circuit is physically opened to break the electrical connection and avoid destroying the entire house when a part of the system fails due to current overload. In the world of distributed systems, you can establish circuit breakers at the integration points between components. Think about edge service and catalog service. In a typical scenario, the circuit is closed, meaning that the two services can interact over the network. For each server error response returned by catalog service, the circuit breaker in edge service would register the failure. When the number of failures exceeds a certain threshold, the circuit breaker trips and the circuit transitions to open. While the circuit is open, communications between edge service and catalog service are not allowed. Any request that should be forwarded to catalog service will fail right away. In this state, either an error is returned to the client or fallback logic is executed. After an appropriate amount of time to permit the system to recover, the circuit breaker transitions to a half-open state, allowing the next call to catalog service to go through. That is an exploratory phase to check if there are still issues in contacting the downstream service. If the call succeeds, the circuit breaker is reset and transitions to closed. Otherwise, it goes back to being open. Figure 9.4 shows how a circuit breaker changes state.
Figure 9.4. A circuit breaker ensures fault tolerance when a downstream service exceeds the maximum number of failures allowed by blocking any communication between upstream and downstream services. The logic is based on three states: closed, open, and half-open.
Unlike with retries, when the circuit breaker trips, no calls to the downstream service are allowed anymore. Like with retries, the circuit breaker's behavior depends on a threshold and a timeout, and it lets you define a fallback method to call. The goal of resilience is to keep the system available to users, even in the face of failures. In the worst-case scenario, like when a circuit breaker trips, you should guarantee a graceful degradation. You can adopt different strategies for the fallback method. For example, you might decide to return a default value or the last available value from a cache in case of a GET request. The Spring Cloud Circuit Breaker project provides an abstraction for defining circuit breakers in a Spring application. You can choose between reactive and non-reactive implementations based on Resilience4J, resilience4j.readme.io. Netflix Hystrix was the popular choice for microservices architectures, but it entered maintenance mode back in 2018. After that, Resilience4J became the preferred choice because it provides the same features offered by Hystrix and more. Spring Cloud Gateway integrates natively with Spring Cloud Circuit Breaker, providing you with a circuit breaker gateway filter that you can use to protect the interactions with all downstream services. In the following sections, you'll configure a circuit breaker for the routes to catalog service and order service from edge service. Section 9.2.1. Introducing circuit breakers with Spring Cloud Circuit Breaker. To use Spring Cloud Circuit Breaker in Spring Cloud Gateway, you need to add a dependency to the specific implementation you'd like to use. In this case, we'll use the Resilience4J reactive version. Go ahead and add the new dependency in the build.gradle file for the Edge Service project, Edge Service. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 9.6. Adding dependency for Spring Cloud Circuit Breaker.
The circuit breaker filter in Spring Cloud Gateway relies on Spring Cloud Circuit Breaker to wrap a route. As with the retry filter, you can choose to apply it to specific routes or define it as a default filter. Let's go with the first option. You can also specify an optional fallback URI to handle the request when the circuit is in an open state. In this example, application.yml, both routes will be configured with a circuit breaker filter, but only catalog route will have a fallback URI value so that I can show you both scenarios.
Listing 9.7. Configuring circuit breakers for the gateway routes.
The next step is configuring the circuit breaker. Section 9.2.2. Configuring a circuit breaker with Resilience4J. After defining which routes you want to apply the circuit breaker filter to, you need to configure the circuit breakers themselves. As often in Spring Boot, you have two main choices. You can configure circuit breakers through the properties provided by Resilience4J or via a customizer bean. Since we're using the reactive version of Resilience4J, the specific configuration bean would be of type Customizer of Reactive Resilience4J Circuit Breaker Factory. Either way, you can choose to define a specific configuration for each circuit breaker you used in your application.yml file, catalog circuit breaker and order circuit breaker in our case, or declare some defaults that will be applied to all of them. For the current example, we can define circuit breakers to consider a window of 20 calls, sliding window size. Each new call will make the window move, dropping the oldest registered call. When at least 50% of the calls in the window have produced an error, failure rate threshold, the circuit breaker will trip and the circuit will enter the open state. After 15 seconds, wait duration in open state, the circuit will be allowed to transition to a half-open state in which 5 calls are permitted. Permitted number of calls in half-open state. If at least 50% of them result in an error, the circuit will go back to the open state. Otherwise, the circuit breaker will trip to the closed state. On to the code. In the Edge Service project, Edge Service, at the end of the application.yml file, define a default configuration for all Resilience4J circuit breakers.
Listing 9.8. Configuring circuit breaker and time limiter.
We configure both the circuit breaker and a time limiter, a required component when using the Resilience4J implementation of Spring Cloud Circuit Breaker. The timeout configured via Resilience4J will take precedence over the response timeout we defined in the previous section for the Netty HTTP client, spring.cloud.gateway.http client.response timeout. When a circuit breaker switches to the open state, we'll want at least to degrade the service level gracefully and make the user experience as pleasant as possible. I'll show you how to do that in the next section. Section 9.2.3. Defining fallback REST APIs with Spring Webflux. When we added the circuit breaker filter to catalog route, we defined a value for the fallback URI property to forward the requests to the /catalog fallback endpoint when the circuit is in an open state. Since the retry filter is also applied to that route, the fallback endpoint will be invoked even when all retry attempts fail for a given request. It's time to define that endpoint. As I mentioned in previous chapters, Spring supports defining REST endpoints, either using REST controller classes or router functions. Let's use the functional way of declaring the fallback endpoints. In a new com.polarbookshop.edgeservice.web package in the Edge Service project, create a new Web Endpoints class. Functional endpoints in Spring Webflux are defined as routes in a router function of server response bean, using the Fluent API provided by router functions. For each route, you need to define the endpoint URL, a method, and a handler.
Listing 9.9. Fallback endpoints for when the catalog service is down.
For simplicity, the fallback for GET requests returns an empty string, whereas the fallback for POST requests returns an HTTP 503 error. In a real scenario, you might want to adopt different fallback strategies depending on the context, including throwing a custom exception to be handled from the client or returning the last value saved in the cache for the original request. So far, we have used retries, timeouts, circuit breakers, and failovers, fallbacks. In the next section, I'll expand on how we can work with all those resilience patterns together. Section 9.2.4. Combining circuit breakers, retries, and time limiters. When you combine multiple resilience patterns, the sequence in which they are applied is fundamental. Spring Cloud Gateway takes care of applying the time limiter first, or the timeout on the HTTP client, then the circuit breaker filter, and finally, retry. Figure 9.5 shows how these patterns work together to increase the application's resilience.
Figure 9.5. When multiple resilience patterns are implemented, they are applied in a specific sequence.
You can verify the result of applying these patterns to Edge Service by using a tool like Apache Benchmark. See this link. If you're using Mac OS or Linux, You might have this tool already installed. Otherwise, you can follow the instructions on the official website and install it. Make sure both catalog service and order service are not running so that you can test circuit breakers in a failure scenario. Then enable debug logging for Resilience4J so you can follow the state transitions of the circuit breaker. At the end of the application.yml file in your Edge service project, add the following configuration.
Listing 9.10. Enabling debug logging for Resilience4J.
Next, build and run Edge service /gradlew boot run. Since no downstream services are running, if they are, you should stop them. All the requests sent to them from Edge service will result in errors. Let's see what happens if we run 21 sequential post requests -n21-c1-m post to the /orders endpoint. Remember that post requests have no retry configuration and order route has no fallback, so the result will only be affected by the timeout and circuit breaker.
See this code?
From the AB output, you can see that all the requests returned an error.
See this code?
The circuit breaker is configured to trip to the open state when at least 50% of the calls in a 20-size time window fails. Since you have just started the application, the circuit will transition to the open state after 20 requests. In the application logs, you can analyze how the requests have been handled. All the requests failed, so the circuit breaker registers an error event for each of them.
See this code?
At the 20th request, a failure_rate_exceeded event is recorded because it exceeded the failure threshold. That will result in a state_transition event that will open the circuit.
See this code?
The 21st request will not even try contacting order service. The circuit is open, so it cannot go through. A not_permitted event is registered to signal why the request failed.
See this code?
Note: monitoring the status of circuit breakers in production is a critical task. In Chapter 13, I'll show you how to export that information as Prometheus metrics that you can visualize in a Grafana dashboard instead of checking the logs. In the meantime, for a more visual explanation, feel free to watch my Spring Cloud Gateway, Resilience, Security, and Observability session on circuit breakers at Spring I/O 2022. See this link. Now let's see what happens when we call a GET endpoint for which both retries and fallback have been configured. Before proceeding, rerun the application so you can start with a clear circuit breaker state /gradlew boot run, then run the following command.
See this code?
If you check the application logs, you'll see how the circuit breaker behaves precisely like before. 20 allowed requests, closed circuit, followed by a non-permitted request, open circuit. However, the result of the previous command shows 21 requests completed with no errors.
See this code?
This time, all requests have been forwarded to the fallback endpoint, so the client didn't experience any errors. We configured the retry filter to be triggered when an I/O exception or timeout exception occurs. In this case, since the downstream service is not running, the exception thrown is of type connect exception, so the request is conveniently not retried, which allowed me to show you the combined behavior of circuit breakers and fallbacks without retries. So far, we have looked at patterns that make the interactions between Edge service and the downstream applications more resilient. What about the entry point of the system? The next section will introduce rate limiters, which will control the request flow coming into the system through the Edge service application. Before proceeding, stop the application's execution with Ctrl+C.